Okay, welcome back. Today we're going to continue with this text display routine, and we left off last time with this setup that allowed us to copy and paste from the character set memory onto the screen memory in the bitmap mode. And we're going to try to make this into what I would like to do is to have a subroutine that I can call, and that subroutine should be able to print out 1, 2 or 3 wide characters, and I'll make special checks for the 4 and 5 sized characters. The reason I want to make it to a subroutine is because even if I do the 4 and 5 block wide characters, I still need to do the 3 first ones in the regular way. And I'll do the I'll use indirect addressing to achieve this, which basically consists of a loop, which I'm planning to use this actually means 18, because I will loop from 17 to 0, including 0. And the reason is that it is 3 lines, which is just straight copy. So here it is actually 18 bytes that is just linearly copied from one location to another. Now, this value here, if it's only 2 characters wide, I can set it to be 0f. And if it is only 1 character wide, I can use 07. So I can use this index register to control how many columns I'm gonna do for each display. And let's use the 0 page register 1 for that one. So basically, in this case it's 17, so we'll fetch from whatever the pointer is for 0 page 1, and it will store it to 0 page register 2. He will decrease the y register, and he will branch as long as y is positive plus. As soon as it goes to minus, that means as when you go from 0 to minus or FF, which is minus 127, he will stop the branch. So this effectively copies 18 bytes. Now I need to set up set p register 1 and 2 in this case. So let's see. We are reading from the character set memory, and we will put this to set p register 1, and don't forget the separation here, and we will write it to the bitmap memory, which is this one. To set p register 2. Now I'm going to instead of using because now I'm gonna keep this one here that we already made, but so I'm gonna just add 320 multiplied with 5, for example, just to move it down a little bit to see that how this looks. So let's just test that and see what happens now. There we go. So this part now actually does the exact same thing as these 3 top lines here. So that is okay. Now, what I'm going to have to do at this point is to increase 0 point register 1, because I want to reuse this loop. So add 18. And store that there. And actually, we're going to have to do that to the low byte of it. And if the carry gets set, we also need to increase the high byte. Right, that looks okay. Now that is the 0-page register. So we add 18, that means we started here, and the loop will print out this one, and this one, and then for the loop to start at this position, I will add 18 to it, which is 8, 10, 18 in hex. So that is the address for where we fetch, and then we also need to update the address where we write it. And if we look here, we go from 320 multiplied with 0, 0, 0, and it goes to 1. So basically I need to add 320 to the 0-page register 2. So it is basically the same thing. There we go, but it's not 18, we will use 40, because 320 in hexadecimal is 140. But we also need to increase this one. So we have to increase that to add 100, and then we add 40, and if it increases the low byte wraps, basically, we increase it again. So that should be it. And then I should be able to use the same loop to write out the next line. Let's see if that works. And it does. So we got that. So we have actually, we're using the exact same loop to do the next line. And then basically we do the same thing again. What we can do then is, for example, this then is the block width. So we'll use the X register to determine what is the width of the block, and we will use the Y register to also control that. There, okay. Yeah, okay. For now, let's keep that there. Okay, so when we come and have updated this pointers, I would like to just do a loop until the X is 0. So, but once you have drawn the last column, I don't want to do this thing again. So basically I want to do the exit code here. So I will decrease X, and if it's 0, exit loop. That should work. Let's put that here, and that means also we need a start loop. We need to reset the Y register, that's why I put that here. It has to be set back to 18. So this should basically allow us to, depending on the width or the setting on X register, should determine how many columns that we are printing out. Let's just see if this works. and it looks to be okay. Let's decrease this one by 1, and it is actually not working as I planned. It's removing a line actually, which makes sense. So this actually has to be 3. Actually, that has to be 3 all the time because they are 3 characters tall. We're only looking at the width. So the only thing that we actually need to change is the Y register. So how many are we going to print out? So based on the character that we are reading, so let's say we read the first here, we get the T, we look up this value, we see the value of T is 3. If the value is 3, we should have the Y register loaded with 17. If it's 2, we should have it loaded with 0F, and if it is 1, it should be 07. That would be the trick. That would be the trick. So that also means X should basically always be 03. Block height, perfect. And we'll leave that to 03. This will allow us to do that. It's a bit same again, a bit of an ugly loop with the exit code inside the loop. I don't like that very much, but still, it's how it's gonna get done. Yeah, that should be all right. This part here. Yeah, no, I think that's fine. Just thinking if there's a way to... Well, I could do that. We're not using the Y register, so we'll load that into Y. We'll increase Y. We'll increase Y. And we'll store it. Not sure if this makes it better or not, but at least the inc command, I believe that uses some cycles, so this maybe is a bit faster. Yeah. Or it doesn't matter at all. Either way. Does it still work? Yes, it does. Now, let's just, for the fun of it, put this to 0F. And then we're only doing 2 columns, and 07 is doing 1. So there we have it. Awesome. Now, this is the part that I would like to make into a subroutine. If I can manage to... something like that. So, and we'll just call that here, like that. And that's good, all right. All right, so the next thing that we're going to have to do is set this part of. Now I'm just manually telling it to fetch it here and write it there. Now where to write it, that is a different chapter. That will depend on the current location of the actual sentence or line he's printing out. So that's the last thing we'll deal with. But where to fetch the data, that has to be done somehow. So if we use the X register for now, and that's where our I didn't bring the, let's see, tables that pointed into memory, which is here, tables. We're going to need this table, so let's just put that here. So char set vector low and char set vector high, that should be good. Now we have a different name for this. No, actually it's still char set, so that's fine. Yeah, that's fine. So that should be just working. Let's just check. Yeah, there's an error here. Symbol char set, low byte char set, because it's a lowercase s. Yeah, that's good. Okay, so then we have our pointers. This basically just fills 96 because it's 96 characters with a multiple of 72 in low byte, high byte format. So based on this one, I want the char set vector low comma x, which then basically tells you which character it is. And we'll put this into set p register 1 low. And we'll do the same for the high. Now, what this effectively does is it based on whatever character x is, or whatever value x is, he will multiply that value with 72. So this is, instead of making a multiplication routine, I use this table like this. Now, this does the same thing as I did up here. So I should not need this anymore. And he should still show a 0, which he does. But now, if I put this to a 1, and everything is correct, it should show A. And there we go. Now, obviously, based on this character that we now read from the X value, we also should determine the width. So, the width table works in the same way. So let's do it like this. We'll fetch the width of the character, and we'll store this into just a temporary zero page value. And we'll use that one here. Instead of, so that means, no, that's not correct. The width table fetches us a value, and this has to be multiplied then with 7, basically. We're gonna use a table for that also, so let's just do that. 0007 0F and 17, and I want 2 more of those just in case it's 4 or 5 characters wide. We'll deal with those special cases later on. So that should set the correct value into the Y register. So let's try it, and the A now shows, and it should also only draw 2 columns. Let's just check that the 0 works. Yes, and now it draws 3 columns. And yeah, we wait with those. That's not important now. We make special cases for that. So now we can control based on whatever value that we are reading into X. We can print that character in the correct width based on this snippet here, and it's working fine. I'm going to use the same print block routine when I do the 4 and 5 character wides. That's why I want it in a subroutine. So this part here is basically just printing out based on whatever we set up in these registers. And we have control over the register 1, 0 page register 1. Now, of course, this part here, where to put it, that will depend, as I mentioned, on the actual position. So, but this is how far we're gonna bring it this time, and we'll pick it up next time where we will try to make several characters appear on a line. So, I hope you followed this rant so far, and let me know if there's anything you would like me to look more in depth or any explanations that you need, and I'll take care of that. So, take care, happy coding, and cheers.